Okay, for first question figure Q3 determine the equivalent resistance RT and total current IT. So let me go on my draw tool, pick pen. So RT is here, right? So you need to determine RT by looking into the resistor circuit. So basically, the most easiest way is to visualize this is that you delete this battery over here and really figure out what's the total resistance RT over here. Yeah. So from this case, we can see that let's start from the top here. Let's do it on the back. It's much easier to simplify from the back. So the equivalent circuit will be first. Let me get a small pen. This thing is too big. Yeah. So you have these three parallel first. This seems the most easiest to be summarized. So in this I3 branch, let's follow this I3 branch first. So in I3, you have R4 split into three branches: R6, R7, R8. Then it sums up back to R5. Then you have another parallel branch coming from R2. And this here is I2. Yeah, just redraw this. Isn't that nice? Okay. And I3. If you could understand, I3 is actually the same of this top part and this top part. Okay. Let me move that. Afterwards, you've done this two branches over here. Your R4, R5, and R2. You are left with the other two resistors, R1 and R3. Okay. So basically, I total is the sum of all these resistors here. So it's your VT, so IR, RT, E. So IT over here equals to VT or RT. This power 1. The voltage drop across R2. Where is R2? R2 is this over here. This over here. So once you already managed to summarize, define this summary of blocks over here. Let me call it R2 prime over here, because this all share the same voltage. So let's say VR2 prime is also VR2, which is R2 prime plus R1 plus R2 plus R3 multiplied by VT, which is, let's get back the original value. Maybe I call this VT, 35. Okay. Third one. Okay. Third question. Change the color with green. Okay. I3 over here. I3 for I3. you need to find the opposite branch. So normally you get, let me see. Okay, R2 is the summary of this whole branch, right? This is R2. Let me do another one. This R2 prime, sorry. R2 prime. This R2 prime. For I3, you need to get the opposite branch, which is this R2 here, over R2 plus this, let me call this another color. Let me get another color. Should I put in blue? Yeah, this blue color portion here. So I call this R3 prime. You need to find R3 prime. R3 prime. So yeah. So basically the current divider rule says that if you have two parallel branches here with a current I total coming in, this is R1, this is R2 of different values, your I1 and I2. So yeah, this is I2. I1 will be R2 over R1 plus R2 times the I total. I2 will be R1 plus R1 plus R2 times I total. So for this schema case, for I3, it should be the opposite branch, will be R2 over here. Then we have R2 plus R3 prime times the I total that you find earlier. Okay, part D. If X is an identical resistor, what do you mean by identical resistors? Each with resistance of Y ohms connected in parallel. Where's X actually? I can't see X. Huh? I think X is a bunch of identical resistors. I think this is a separate question. I think, yeah, this is a separate question. So let me scroll down a bit. If X is an identical resistor with resistance of I ohm connected, maybe let's say this X, then this is at Y ohms connected in parallel, like so. The total is not a series in parallel. If X, then you connect it in parallel, like so, in 20 words or less. I will just say R total is equals to 1 over R1 plus 1 over R2 plus 1 over R3 and so on. So R total would be smaller with each additional parallel resistor X added into the parallel chain circuit. Okay, parallel chain as such. So yeah, this is a sub question. So yeah, that's all. Goodbye.